So,
and energy is one of the things that I've has been my main topic for quite a while on the huge amount of energy that goes into this, and I have some data from one of the guys who worked for essentially doing AI governance for vehicles, who was showing that the slope of consumed energy versus produced energy has the potential to intersect sometime in the next few decades, and the slope of data center energy as opposed to consumed energy is very different. The data center usage energy is increasing far faster than the overall energy demands, and it's driving the overall energy demand. So these are of course very big concerns. The thing that alleviates this a little bit is there are various different forms of clean energy that are coming online to do this. Huge amounts of solar are now available, and there's talk about recommissioning some of the nuclear power plants, which are clean until they're not. But I mean, those are a couple of things there. But it's the other issue that I have with an awful lot of this energy consumption is at the end of the day, it all ends up being dissipated heat as well. The unfortunate fact of the matter is that a data center does no real work. Every watt you put into it gets turned into heat.
Yeah, the thing that comes out of it is heat. It doesn't transform incoming raw material from one format to another. All it does is radiate. And a large part of the design of a data center is making sure it radiates that heat efficiently. So we have some concerns on future energy supplies and availability. We really do, I think, hope that the current trajectory of larger models, meaning larger amounts of resource to achieve, well, the same things we used to do, doesn't continue too badly.
I was going to say, let's bring this full circle and say, if we actually attack this problem by trying to be more efficient in the software that controls this, and coming up with more efficient ways of making use of the resources that you have available to accomplish the same results, right there is a big way to save an awful lot of the energy associated with it.
It's really interesting. I just keep thinking about, coming full circle again to your point there, Andy, it's funny how in IT, we keep coming back to the same, what was old is new again sort of things. And 20-something years ago, when I was at Apple, Bobby Chavanian was our head of software, Steve Jobs' sidekick. And when I was on the engineering side at that time, and, they gave us small memory systems. So the shipping machines were, I believe, 256 meg of system RAM. And they basically, on purpose, gave us 128 or less. And that was to ensure that we were building with the idea that we have limited resources. We're not building with the idea that there's limitless RAM, there's limitless capacity. And I'm not sure how that lesson can necessarily be applied in a world where what we're discussing here, right? You need some heft to do some of these things. It gets back to the whole optimization side of this, though, and it's kind of like back to my point earlier about product development versus actual production, what mode we're in. If we're building for what can we do with this, right, as opposed to we're building for this needs to be sustainable and maybe environmentally responsible, and by the way, not costing us more than we intend to spend on our payroll for the next 3 years. That those things have to all come in line to some extent. And I'm not sure what that reckoning looks like, but I think it was said earlier, maybe by Brian, the constraints will push the innovation as it always has. And I think that's, maybe we're kind of repeating ourselves saying that, but I think that's kind of where we're probably headed.